Welcome my friends in Metallurgical Discussions channel. Today we will learn and explain what's piping system for power plant fundamentals and petrochemical plants. Piping system, what is it? Concept, layout development, piping components, their access requirement, straight length requirements, orientation of various tappings, components and so on, piping drains and vents, insulation, material, sizing, BDT, VDT selection, critical piping system consideration, piping stress analysis, piping supports, special considerations, and finally we will discuss piping designer's input and output. Piping system. First, we should know and explain what is pipe first. The pipe, it is a tubular item made of metal, plastic and glass and so on, meant for conveying liquid, gas or anything that flows. It is a very important component for any industrial plant, and its engineering plays a major part in overall engineering of a plant. Piping system. What is piping system? Now we will try to understand step by step how a piping system is formed based on the requirement. We shall start with a plain white sheet. This is a plain white sheet we start with. Let us start drawing a simple piping system. We will show sample for drawing. Show 3 tanks. Tank number 1, tank number 2, tank number 3. In any plant, various fluids flow through pipes from one end to other. Now, let us start with the plant where we see 3 tanks. Tank 1, 2, 3. We have to transfer the content of tank number 1 to other tanks by piping. We need to connect pipes to transfer the fluids from tank number 1 to tank 2 and 3. Pipes. This is pipes. Okay? We have just brought the pipes. Now we need to solve some more problems. What is the problems here? Connection between pipes. How to connect these pipes. As we said before in the last video, we use fittings, okay, to connect the pipes, because these pipes are straight pieces. Here we need some bend connection. Here we need some branch connections. Even some pipes are of different size. This size differs than this size. To solve these problems, we need the pipe components, which are called pipe fittings. Like this. This is reducer to reduce the size. T. Here we see elbow, 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 elbow. There are various types of fitting for various purposes. Some common types are elbow and bends, T's and branches, reducers and expanders, coupling, eyelets and so on. Okay, what is the problem here? As we see, in a way, the pipes and fittings are in place, but the ends are yet to be joined with the tank nozzles. We now have to complete the end connections. These in piping term we call terminal connections. Here we see flange. Okay. These are flange joint. Tank number 2 and 3. For tank number 1 we see welded joint. So far this is a nice arrangement, but there is no control over the flow from tank number 1 to other tanks. No control for the flow. How to control the flow? We need some arrangement to stop the flow if needed. To control the flow in a pipe, we need to fit a special component. This is called valve. As we see here, this is valve to control the flow. Here, valve. There are many types of valves categorized based on their construction and functionality. These are gate valve, glue valve, check valve, butterfly valve, and so on. Other than valves, another important line component of pipeline is a filter. which cleans out debris from the flowing fluid. This is called strainer. Here we put strainer to clean the line. We see more or less functional piping system with valves and strainer installed. Let us now investigate some aspects of pipe flexibility. If this tank nozzle expands when the tank is hot, okay, in such a case we need to fit a flexible pipe component at that location, which is called expansion joint. Like here, we should put expansion joint. Okay. When some fluid is flowing in a pipe, we may also like know the parameters like pressure, temperature, flow rate of the fluid. To know this information, we need to install instruments in the pipeline. Instrument like flow meter, pressure gauge, there are various types of instrumentation to measure various parameters. Also, there are specific criteria for installation of various pipeline instruments. Next, we shall look into how to support the pipe and its component. Here we see supports, hanger support, here support, here training support. Okay. Here some of the pipe supporting arrangements. There can be numerous variants. All depends on piping designer's preference and judgment according to designer and piping stress analysis. This is strut, here spring box, we have just completed a pipeline design. We shall rewind and check how it's really done in practice. First, the flow scheme is planned. What? Number 2, from what point? Number 3, to which point? Pipe sizes are selected, pipe material and pipe wall thickness are selected according to design. Types of valves are planned. Also, the types of instruments required are planned. We represent the whole thing in drawing, which is called piping and instrumentation drawing. In short, P and ID. This is short for P for piping, I for instrumentation, D for diagram, piping and instrumentation diagram. Okay. For P and ID generation, we use CAD software. By the time you have already come to know the while we prepare P and IDs in CAD, we enter all the pipeline system information in the drawing. So the CAD drawing is an intelligent drawing which under its surface carries all the information about the pipe, like pipe size, flowing fluid, and so on. Let us see P and ID prepared in CAD. This sample for P and ID piping and instrumentation diagram prepared by CAD software. This screen picture of P and ID made by CAD. If we click to any line, it will show the data embedded. If we click here, we will see here all data required about this line: description, furnace specification, unit for plant system, pressure, temperature, design condition, and specifications. Okay, piping design table, all data required about this line. In another video, we will discuss and explain what is P and ID, how to read P and ID. Now we reach the end of the video. Thanks to all my friends. Goodbye.